Good day, future doctors and medical technologies. So let's continue with our topic in CC1, optical techniques. Okay, so our topic for today, we're going to talk about cuvettes. Since we already discussed the components of your spectrophotometer, now we're going to talk about the succeeding parts of this topic. Okay, for the components, we use cuvette. Remember, in Beer's law, cuvettes are the thickness of the cuvettes are usually given. No, it can be 2 centimeters thick, 5 centimeters thick, depending on the brand and the machine. Okay, remember that these are analytical cell sample holder, so they used to hold the solution in the instrument whose concentration is to be measured. Made of materials that does not absorb light in wavelength range of interest. Remember, it will defeat the purpose of using cuvettes in spectrophotometer if it can interfere with the absorptions, no, or the absorbance of light, because in spectrophotometer we want that the sample will only be the one who will be absorbing light and then emitting excess light to be measured by your photodetectors. Okay, so we have different types of cuvettes. We have the borosilicate glass, quartz, alumina silica glass, and soft glass. So remember, these are the different types of importance or things to remember about these cuvettes. So for borosilicate glass, it is for alkaline solution. Quartz or plastic cuvettes, they are for wavelength below 320 nanometer. Alumina silica glass, they are good at visible region. And soft glass, preferable for acidic solution. Okay, so when which light is measured by the photodetector, light absorbed or light transmitted. So please take a look at this. Okay, so this is your spectrophotometer. Your sample here is nandyan siya, being held by the cuvette. So now the question is, anong light ba yung gina-absorb ng yung photodetector? Light absorbed or light transmitted? We say light absorbed by the solution. Okay, when you say light transmitted refers to the light, excess light coming from your sample. Okay, so diba, meron tayong initial light, yung dito. Okay, and then it will pass through the sample. If there are let's say you're testing for glucose, if there are abundance amount of glucose, the initial light, no, will be much higher than your excess or your light transmitted. So now the question is, ano ba yung gina-measure ng ating photodetector? So we will answer that later on. Okay, so remember that we can do these techniques because we are already in the advanced modern era. Okay, so now let's ask the question, can we measure light? So can we nga ba? Okay, so let's see. Okay, so in order to measure light, you need to have photodetectors. It converts transmitted light energy into an equivalent amount of electrical energy. So ibig sabihin, no, from the question kanina, ano ba ang answer doon? It is the light transmitted. Ibig sabihin, the light that is being excess from the light absorbed will be measured, will be the one measured by your photodetector. So we have different types of photodetectors. We have the barrier layer cell, photoemissive or the phototube, as well as the photo multiplier. Okay, so we're going to discuss it one by one. Your barrier layer cell or photocell or the photovoltaic is composed of light sensitive materials. No, example, selenium or iron plate with transparent layer of silver. Okay, remember that when exposed to light, electrons in the light sensitive material, because this barrier layer cell is composed of light sensitive materials, they are excited and are released into the highly conductive silver. Okay, so yung ating yung ating ilaw dito, guys, no, yung excess light will make the electrons, no, excited. Okay, so remember, based on this definition, you can clearly see that this is very plain and simple. That's why it is least expensive and no need for a power source. Okay, so this is the simplest form of a photodetector. You also have yung ating tinatawag na photoemissive or phototube. Okay, it is similar to barrier layer cell in that it has photosensitive material as well that gives off electron when light energy strikes. Remember, pag sinabi yung photosensitive material, no, it will give electrons, no, when matamaan siya ng ilaw. Composed of positively charged anode and negatively charged cathode that is enclosed in a glass. Okay, so when light strikes the cathode will emit electrons. Okay? Therefore, the electrons will accelerate or move towards the anode. Okay, so you have your light here. Then when light strikes the cathode will emit electrons. Then the electrons will accelerate or move towards the anode. Okay, the flow of electrons will make a current. Okay, and then it will lead to a number of photons. So since this requires, okay, so yan, cathodes, anodes, and electrons, okay, it requires an external source of energy. For your photomultiplier, or what we call the PM tube, okay, once light strikes the coated electron, electrons are emitted. The electrons now are attracted to a series of anode known as dynode. Okay, so it has the same principle as your phototube. However, since tawag yan, we have multiple anodes here, or series of anodes, in which in this case we call them dynodes. Okay, tawag yan, it will be, no, it will be amplified. Okay, so the dynodes gives off secondary electrons once hit by single electron. So ibig sabihin yung kanyang the movement of your electrons are much denser, okay, compared to your phototube. Okay, the PM tube can amplify the amount of light energy, therefore it can measure even the very low light levels. Okay, since marami siyang series of anodes, guys, okay, so again, kahit na maliit na yung light energy, no, yung light levels na ma-emit galing sa inyong after matama, di ba, yung solution ninyo, may solution kayo dyan, kahit konti na lang yung ilaw na ipalabas ng inyong solution, okay, yung substance natin dyan, it can easily be picked up by a photomultiplier because it has abundant, okay, amount of anodes. Okay, so even very low light levels, it can detect can detect or amplify the amount of light energy. Okay, so let's move on to the next slide. So this is a picture of your photomultiplier. As you can see, it is a very complex photo multiplier equipment, diba? So we have dynode chains, no? Meron tayong mga ito, yan sila. Okay, so yan sila, guys, no? Yung mga dynode chains na yan, yung mga anodes na yan, yung napakarami na yan, will pick up, okay, will pick up multiple electrons. Okay, so remember that. So we also have, after nyan mabasa natin yung light na transmit, no, we need something para makita kung ano yung amount ng light na transmitted. Okay, so once again, when we say light transmitted, it is the light coming from the excess, no. Kasi for example, yung initial light natin, we have 20, and then yung ating sample konti lang yung kanyang glucose, no, it can only absorb 15. So the excess light or the light transmitted will be around 5. Okay, so therefore meron dapat the phototube natin or the photo detector natin should be able to display, okay, the amount of light transmitted. So it can be using a meter, using a digital, or it can be a recorder. Okay, ito siya. Okay, so let's talk about the different types or other types of spectrophotometry. So simula kanina, no, since the last meeting natin, guys, no, we talk about the single beam spectrophotometry, basically the very basic level of spectrophotometry. But we have different types of spectrophotometry which shares the same principle, but the components may differ from each other. Okay, so now let's talk about the double beam spectrophotometry, plane emission spectrophotometry, and the AAS, or the atomic absorption spectrophotometry. How do they differ with each other? Okay, so let's move on to the next slide. From the word double beam spectrophotometry, no, from the word double beam, you can therefore deduce that it has double beam. No, joke lang. Okay, so you can deduce that it utilizes two beam of light, reference beam, which is something that you have here, okay, as well as the sampling beam. Okay, ayan. Okay, so from the initial light source, no, meron tayong entrance slit, exit slit. Okay, diretso sa ating beam splitter. So the light will bounce to your sample cell as well as your reference cell. So your sample cell is where the samples are being held. Okay, and then you also have a photodetector here as well as a photodetector here. Okay, so yun yung ano niya guys, no? Kaya siya double beam because meron ka pang reference cells. Okay, so we have two types of double beam spectrophotometry. Okay, you have your double beam, no, we'll just call it double beam in space, or double beam spectrophotometry in space. Okay, so can you please take a look at the main components of a double beam in space? You have your sample cell here as well as your reference cell here. Okay, so after that, no, yung matama na dito yung light, ma-absorb na ng component ninyo, then meron tayong transmitted light, it will be detected by a photodetector. Same thing with the reference cell. Okay, it will be detected by a photodetector. Okay, so since based on the picture, you can see that a major drawback of this type of instrument is the requirement of two detectors, okay, which makes the instrument more expensive. Yes, okay, so remember that sample and reference are measured simultaneously, and the signal from the reference, no, yung signal dito, is subtracted from the sample signal. Okay, and then it will be read, okay, by a reader. Okay, so we have three types of reader, di ba? Okay, so that is for the double beam in space. We also have the double beam spectrophotometry in time. So double beam spectrophotometry in time, okay, has the same, no, principle. However, take a look at this, no, meron siyang tinatawag na rotating chopper. Okay, so the chopper here is a device consisting of a circular disc. 1/3 of a disc is opaque and the 1/3 is transparent. The remaining 1/3 is mirrored. Okay, anong ginagawa nito? It splits the monochromatic beam of light into two beams of equal intensities. Okay, remember, in other instruments, the two beams pass through a beam chopper which blocks one beam at a time. The detector alternates between measuring the sample beam and the reference beam in synchronization with the chopper. So, ibig sabihin, here, in the double beam spectrophotometry in time, okay, makikita ninyo na we only have one detector. Okay, one detector. Compare niyo sa inyong space, okay, meron tayong two detectors. So to better memorize this or better remember this one, remember space has two syllables, no? S space. So wala lang, S space. So 2 times yung binanggit, so dalawa ang kanyang detector. While time only has one, so therefore one detector para mas madali siya. Okay? So ano siya guys, no? The rotating chopper here, no, will tawag yan, alternate between yung readout ng measuring the sample beam and then the reference beam, no, the cuvette sample as well as the reference cuvette, mag-alternate na siya. Okay, and then diretso na siya sa readout. Okay, so remember that your double beam spectrophotometry, okay, light is directed forward into directions by a rotating chopper. One light path is directed forward to the sample cuvette, while simultaneously the other is directed towards the reference cuvette. So ingana siya guys, no, para siyang tawag yan, paikot-ikot. The sample beam is compared to that of the reference beam. So basically guys, a double beam spectrophotometry, you know, it may be expensive, no, much more expensive. However, tawag yan, it can be maingon niyo na mas better because meron tayong reference, no, reference cuvette. Okay, so depende maganda siya sa specimen na inyong ginatest. Okay, so that is for the double beam spectrophotometry. Okay, so let's move for the flame emission spectrophotometry. So remember that in flame emission spectrophotometry, with the development of ion selective electrodes for these analytes, flame photometers are no longer routinely used in clinical chemistry laboratory. We have group 1 metals, no, such as your sodium, potassium, lithium, rubidium. Okay, sulat na lang. Rubidium, caesium, okay, as well as the francium. Okay, so ano bang principle ng flame emission spectrophotometry? Involves measurement of electromagnetic radiation emitted by the excited atoms in the flame. Okay, so ano siya guys, tawag yan, dili na siya ginagamit karon because we have developed ion selective electrodes, no, for this specific analytes. Okay, so tsaka ano po siya, ganyan, dili siya routine na ginagamit sa laboratory. Okay? Tsaka dagdag ko lang din, no, na since from the word flame, no, flame, ayan. So meron talagang apoy dyan, guys, no, na ginagamit. Okay, but sige lang, ma-discuss ko yan later on. Okay, but para bigyan kayo ng idea, no, sa kanyang principle, so here is a diagram. Okay, so in plane emission ng spectrophotometry, paano nga ba nagkakaroon ng emission? Okay, so remember that the electrons do not just move around randomly, but they occupy specific regions known as the energy shell. So they occupy certain regions, guys. Okay, within the energy shell, the electrons can be found within the cloud-like regions called orbitals. Okay, so orbitals yung tawag kung saan yung area na nandiyan yung inyong electrons. Okay, so normal lang, walang problema, nandiyan lang siya. Okay, the electrons that are found in the outermost occupied orbitals of an atom known as valence electrons, no, do not always remain in the same orbital or energy level, as they are able to absorb energy from heat or light. So there are some electrons, guys, no, lalo na yung mga valence electrons natin, okay, na nasa tawag yan, outermost orbitals po. Okay, so they can absorb energy, okay, from heat or light. Okay, so hindi lahat ng electrons, only the valence electrons. Okay, so when a valence electron absorbs energy, it enters what is known as an excited state. So let's say for example, this is your valence electron, no, minding its own business. Kapag merong energy dyan na pinatama mo, no, it will cause the electron to be excited. So again, the excited state can commonly take form of an electron jumping from its original energy level or the orbital niya, okay, kung saan lang siya nakastay, also known as the ground state, to an empty orbital of a higher energy shell that is further away from the nucleus. So the electron may move. Okay, the electron may move. Kaya kung makita niyo dito, di ba, nag-move yung electron natin, no? Nag-aalis siya sa kanyang original na orbital, which is this one. Okay, the electron moves away from the nucleus. So, okay, so remember that to again, yung kanyang pagiging excited, okay, the excited state does not last long. Okay, the excited electron does not stay in the excited state permanently. However, it will eventually falls back to the ground state. So it will eventually go back to its orbital. Okay, ayan, yung parang sa orbital niya. After niya magkalat, no, babalik na naman yun siya sa kanyang pinanggalingan. So yun tatandaan nyo. So ngayon, bakit ko explain yan? Because when the electron falls from the excited state, it loses energy in the form of light. So remember, after ninyo ipa-excite yung ating electron, di ba, nandito na yung valence electron natin, normal lang. Kapag ma-excite na siya, mawawala siya sa kanyang orbital. And then, it will cause the electron to jump or move around, no? From, ito pa yung nucleus, di ba? It will move around away from its orbital, no? Causing movement. Yan, like ito. And then, eventually, it will stop. And then, yung moment na pagbalik niya sa kanyang orbital, again, it will emit energy. Or, mas better term, it loses energy in the form of light. And that process is what we call emission. Okay? So, in flame emission spectrophotometry, you are causing electrons to be excited, and that excitation, kapag magbalik na siya sa kanyang original state or sa kanyang ground state, no, the action of losing energy in the form of light is what we call emission. Kaya siya tinawag na flame emission spectrophotometry. Okay, so let's see. Okay, so this is the component of a flame photometer. As you can see, no, ganyan sinabi ko kanina, meron talaga tayong flame. Okay, so since grabe na to ka old and is not really used nowadays, okay, sa flame photometer, guys, remember that yung principle natin kanina. So, you have your flame here, tama? Okay, you have your atomizer here. The atomizer here is now being directly introduced to your sample. Okay? Since nasa sample na yung inyong tawag yan, inyong atomizer, okay? Yung flame na nandito will cause now the movement or the excitation of the electrons present in your sample. Na-get so far? So when the flames, okay, when the flame or the light, no, yung excitation na nandito nangyayari, no, 'di ba, meron ma-lose man yung energy kaya mag-stop man ang excitation at some point. Lahat ng light na ano diyan, guys, no, ma-emit, okay? Ma-emit will now be process, okay? Will go into your entrance slit once again, do the grating and then the slit. And then, mabasa na siya ng photo multiplier. Depende, maguna siya kung ano yung test na gagawin mo. But can you see the difference of this from your spectrophotometry? Kung sa spectrophotometry, you had your light source, diba? And then, meron kayong entrance slit, tama? And then, you also have your monochromators here, tapos exit slit, diba? Tapos, tsaka pa magkaroon ng sample. Dito yung sample natin, then photo detector, then, or amplifier kung meron, then read out. Here, no, you had your sample here, no, nasa baba siya, and then, you are merely causing the electrons present in the sample. No, depende kasi kung anong test ang gagamitin mo. So, let's say, if you're trying to test for sodium. Okay, sodium, meron silang mga electrons, diba? So, ngayon, yung flame na pipiliin mo guys, no, yung the amount of flame na gagamitin mo is needed on the amount lang po sa inyo kang sodium na present sa sample. So yung sodium dito, no, mga sodium electrons, there will be, ma-excite sila, depende kung gaano kadami. And then, pagkatapos nila ma-excite, no, they will release light. And that light will go through sa slit once again, then sa prism, or grating, no, and then another exit slit, then photo multiplier, and then amplifier, hanggang sa mabasa natin yung exact amount ng ating sodium, in this case sodium, no, sodium, mabasa siya. Okay? So remember, sir, bakit nga ba mabasa yung sodium? Because remember, your sodium, 'di ba? Meron siyang electrons, okay? So, yung electrons na present sa sodium mo, yun yung ginampa-excite ng flame mo, causing it to do the emission, no, emission of light. Okay? So I hope na gets niyo yung gusto kong iparating sa inyo, ha. Okay, so let's talk about the atomizer for a second. Okay, so your atomizer breaks up the solution into finer droplets so that the atom will absorb heat energy from the flame and get excited. Okay, so your atomizer na kung saan yun yung nilalagay, no, nakatusok sa inyong sample, no, it will break up the solution into finer droplets so that the atoms will absorb heat energy from the flame and get excited. Remember, ano yung mga ginatry natin at i-check dito? You have your sodium, potassium, lithium, diba? Francium, rubidium, as well as your caesium. Okay, but nowadays, since meron naman tayong specific ion electrodes, no, for those analytes, no, kaya hindi naman siya ginagamit ang flame emission, guys. Okay, kaya ano na siya, again, dili na siya common ninyo makita sa mga laboratories. Tsaka hazard po din, no, merong apoy. Okay, so since nabanggit ko yung word na apoy, flame, no, the purpose of flame is to convert the analyte of the liquid sample into vapor state and breaks the chemical bonds to produce atoms. Okay, the source of energy that will be absorbed by the atoms to enter the excitation state. So remember kanina, di ba, in order for the electron, okay, the electron to move out of its orbital, okay, or ground state, it needs to have the energy. Kailangan merong energy na magtama sa kanya, okay, para mabuang siya. Same lang gud na anang kanang pamakita nimo imong kanang the one, no, walang pasabi-sabi, guys, no, bigla na lang mabuang na lang jud ka, dili wala ka kabantay na ingana na excite na kagtaman, ingana siya. Same principle with the flame. Kaya nga guys, kung nakalaro kayo ng palatandaan ko dati dito, no, when we talk about flame emission spectrophotometry, I always remember yung flames good na ano yung friends, lovers, yung ganun, because halos it shares the same principle, mga good guys, no, na ma-love struck ka, no, ma-excite ka, and then hindi ka man always ma-excite ka, may time na mawala na siya, so you will lose energy, diba, in the form of light, yung ganun siya. Okay, so we also have since we have the flames, no, so let's talk about yung burners. We have different types of burners. You have total consumption of burners, no, the sample is aspirated directly into the flame. All the sample that enters the capillary will enter the flame regardless of the droplet. Okay, so remember that the advantage of this is the design is simple and the entire sample is consumed. The disadvantage of this, uniform and homogeneous flame is not obtained. Droplet size may vary, leading to fluctuations in the flame intensity. That is the total consumption burners. Okay, so remember, when using total consumption burners, the entire sample is consumed. Okay, so wala yung mabili na specimen sample. Yung nilagay mo dyan, maubos talaga siya. We also have yung tinatawag natin na pre-mix burner. Aspirated sample, fuel, and oxidant are thoroughly mixed before reaching the burner opening and then entering the flame. So here, remember that again, the entire samples are not consume because you are going to aspirate the sample that you need together with the fuel, then the oxidants, di ba? Mix sila, then before sila ipasok sa apoy. Only a small portion, about 5% of the sample reaches the flame in the form of small droplets and is easily decomposed. So, ibig sabihin, unlike your total consumption burners, no, na maubos talaga lahat, okay, dito, only small portion lang ng sample niyo ang magamit. Advantages of this premix burner is non-turbulent, noiseless, and stable. Easily decomposition which leads to high atomization. Okay, so gusto ko ipakita sa inyo guys, na ipa-remember sa inyo that we have different types of colors of the flame observed depende sa inyong element. Okay, so we have the flames in flame emission spectrophotometry. Okay, we have the name of the element emitted. So let's say for example yun yung element na gamitin nyo. Okay, so pag potassium 766 with a observed color of the flame na violet. Okay, so yung violet na yan na ilaw na yan guys, no, yan yung papasok sa inyong entrance late diretso na hanggang sa inyong reader. Okay, okay, ito yung wavelength niya. We also have lithium 670, calcium, sodium, and barium. Okay, so these are just examples, no, ng inyong please read more sa inyong book because I think medyo marami-rami to sila. Bakit to sila kailangan, sir, namin malaman? Because, no, though dili na siya kaayo gina-perform nowadays, no, tinatanong kasi siya sa board exam, guys. Okay, remember, our board of examiners are quite old, so sometimes they tend to ask questions from their time. Okay? So, kami, ang laging lumalabas sa mga pre-boards namin is itong sodium, no, which is yellow. Okay? Yung kanyang color ng flame. Tapos, the wavelength is 589 nanometer. Okay, so I hope klaro siya, no. So we also have yung kanyang, remember, tandaan niyo to guys tandaan niyo yung kanilang mga color ng color na ginapalabas nila because meron tayong tinatawag na interference filter, remember. So let's say for example you only need to test potassium. Okay, so you will use a potassium filter and then it will only transmit yellow light. Okay, so let's see. Ayan. For the interference filter guys, no, remember that for the sodium filter, transmit only yellow light at 589 nanometer. For the potassium, transmit only yung tinatawag natin na violet light, which is mabasa siya at 367 nanometer. And then, yung ating lithium na transmit only red light, no, which is can be read at 767 nanometer. So, lahi-lahi sila color guys, no, depende sa inyong again, analyte. Okay? So, we also have yung tinatawag natin na atomic absorption spectrophotometry. But before that, let's have a recap, no? You have your sample here. Okay? From the sample, this is your atomizer. Maalala? Then, this is the light. Okay? So, it may, so again, the light here will excite the electrons present in your sample and then it will emit light, 'di ba? Kasi nga once na mag-stop na yung excitation, magkaroon na tayo ng emission, and then to be detected by your detector. Yung ana siya, guys. Okay? So, let's proceed sa next spectrophotometry natin, which is the atomic absorption spectrophotometry. Okay? So, remember, your atomic absorption spectrophotometry is different from your double beam as well as your flame emission. Okay? So, here, sa ating atomic absorption spectrophotometry, we have group 2 metals. Okay, kung kanina group 1, so ngayon we have group 2 metals and then we have the 2+ charges. And remember, it is not easily excited but can absorb light. Okay, yan yung mga group 2 metals natin. Okay, the principles of atomic absorption spectrophotometry or the AAS, no, is that it measures concentration of element by detecting absorption of electromagnetic radiation by the atoms. Okay, so yan yung kanyang principle. Okay. In your atomic absorption spectrophotometry, remember that the elements are not excited, but they are dissociated from their chemical bonds. So this is very, very different from your flame emission spectrophotometry. Remember, pag excited, flame emission, no? Pag walang excitement, no, unexcited yung ating electrons, no, unionized, they use the atomic absorption spectrophotometry. So paano nga ba yan nangyayari? So you have the absorption of radiation from light source by the pre-atom. The ground state atoms absorb light energy of a specific wavelength as it enters the excited state. So remember that, di ba, you have your atoms, tama? when your atom, when your electrons, no, when your electrons are in their orbital, no, that is what we call the ground state, tama? Kapag nag-alis na siya sa kanyang ground state, no, it will become excited state. So dito, sinasabi lang dito that the ground state absorb light energy of a specific wavelength. So merong wavelength na i-introduce, okay? And then it will enter the excited state. Ngayon, ang tinitingnan lang dito guys, no, as the number of atoms in the light path increases, the amount of light absorbed also increases. So, ibig sabihin, before mag-excite itong electron natin, 'di ba? Before mag-excite, you need to hit it with certain amount of energy, tama? Okay, para siya ma-excite. So ngayon, before siya mag-excite, no, gina-determine dito is yung amount ng energy na it will cause for the electron to excite, to be excited, okay? So it will absorb light, no? It will absorb light, and then again, it will be excited. Okay? So as the number of atoms in the light path increases, the amount of light absorbed also increases, which makes it na mag-excite, begin excited na siya at some point. By measuring the amount of light absorbed, remember, absorb, a quantitative determination of the amount of analyte can be determined. So basically guys, no, you're not determining the after na, 'di ba, after ng excitement niya, mag-release man siya ng energy in the form of light. Dito sa atomic absorption spectrophotometry, hindi mo hintayin na maging excited yung inyong electron, but rather ipaano lang siya guys, no, send lang ng energy, ng light source or ng energy sa inyong electron, okay? Yung amount of time, okay, the amount of light na na-absorb niya before siya ma-excite, okay? If ma-determine natin yun, therefore we can do a quantitative determination of the amount of analyte. Nagets ninyo? Because you can clearly see how much light ang kanyang na-absorb before siya ma-excite. Okay? So in atomic absorption spectrophotometry, remember that the only function of the flame here, no, is to convert the sample into aerosol. Sample aerosol into atomic vapor, which can then absorb light from the primary light source. So from your primary light source, no, ang purpose na talaga ng inyong flame dito is not as the source of your light, but rather, no, it will make the electrons na ma-excite siya. Pag malapit na siya ma-excite, yung amount of light na kanyang na-absorb, no, yung amount of light, let's say for example, ito yung electron natin na nasa ground state siya. 'Di ba? Pag ma-excite na siya, mag-jump around naman na siya, mabuang naman na siya, mag-liuk-liuk naman na siya. So ngayon, ang gina-measure natin dito is yung amount of light absorbed niya before siya maging excited. Yun lang yun siya guys. Mura dito yung pasabot dire. Okay? So, para mas madali siya maka-absorb ng light, ang purpose lang ng flame dito is to convert the sample aerosol into atomic vapor. Marag vaporize niya ang specimen nimo. Mura dito ang function sa light. Not to excite the light. Okay? So, kapag nagawa na ng flame yung trabaho niya, no, na-convert niya na yung sample aerosol into atomic vapor, ngayon, the vapor now, or your sample, can absorb light directly from your, okay, primary light source. Okay, so let's see. For the components, the light source here is the hollow cathode lamp, no? Hollow cathode lamp ang kanyang light source, so dili itong flame. Okay, so we also have the mechanical rotating chopper. Alam naman ninyo ang rotating chopper na yung nagaikot, di ba? Yung nagaikot-ikot, yan. Matuyok na siya. Modulates light beam coming from the light source. The burner uses flame to dissociate the chemical bonds and form pre-unexcited atoms. So the flame here just converts, di ba? Converts your aerosol to a vapor, or mas easier siya maka-absorb ng light. We also have a monochromator. Alam naman ninyo, it selects the desired wavelength from a spectrum of wavelength, no? Depende kung ano yung gusto ninyo na i-test. We also have a detector and then a readout device. Okay? So, para maka-gets mo klaro, no? Meron tayong drawing dito. Okay? So, ano siya guys? Ayan. So, dito guys, no? Here is your sample. Okay? Your sample. Your sample now will be malagay sa atomizer natin together with the flame. Okay? But the flame here is not the one making the sample excited. Okay? But rather, pag ipa-convert niya yung inyong sample into vapor para mapunta dito, no, para mapunta dito yung sample natin. Kapag nandito na yung sample natin, before siya maging excited state, no, meron tayong hollow cathode lamp that will pass through light sa inyong sample. Okay? Yung kanyang at ground state, no, before siya maging excited, no, it has the ability to absorb the light from your hollow cathode lamp, which is the primary light source in your atomic emission spectroscopy or atomic absorption spectrophotometry. Okay? So yung ma-absorb na ilaw na light dito guys, no? Will go through the entrance slit. Tuloy-tuloy na siya guys up until your readout device. Okay? So I hope klaro siya, no? Na-gets ninyo ang gusto kong sabihin sa inyo. Okay? So meron tayong tinatawag na relationship between atomic emission, no? As well as yung ating atomic absorption. Okay? So ang atomic absorption spectrophotometry and atomic emission spectroscopy, okay, meron silang difference. Okay, ang atomic absorption, gumagamit sila ng hollow cathode lamp, no? Ang atomic emission guys, no, kay it uses the same principle but not cathode lamp ang ginagamit nila. Okay, so let's see the relationship between your atomic absorption naman as well as your flame emission, because diba dito nagagamit din naman ng flame. Okay, so flame emission, it measures the radiation emitted by the excited atoms, no, that is related to the concentration. Your atomic absorption, it measures the radiation absorbed by the unexcited atoms that are determined. Okay? So, magkaiba yun ha, magkaiba. So, flame emission, ginapa-excite yung atoms, no, using the flame. While sa atomic absorption, hindi. Atomic absorption depends only upon the number of unexcited atoms. The absorption intensity is not directly affected by the temperature of the flame, whereas the flame emission intensity, in contrast, being dependent upon the number of excited atoms and is greatly influenced by the temperature variation. So that's why guys, dili na kaayo ginagamit ang inyong flame emission spectrophotometry. Aside sa hazardous siya, no, nang gumagamit tayo ng flame, there are certain factors din talaga kung titignan ninyo, no, kasi nga maka-influence yung temperature to make the, kasi here you are measuring the excited atoms okay, excited electrons, but if the temperature is too high, the flame is too great, no, there will be lots of excited atoms, tama? So therefore magiging it could lead to a misread ng inyong result, no? So inyong atomic absorption naman, nakadepende naman siya sa amount ng unexcited atoms naman. Okay? So, dili mapektuhan ng temperature ng flame yung ating readout. Okay? So, for the atomic absorption spectrophotometry, no, you need to understand that we have interferences, no, chemical and ionization. Okay? So, remember, in AAS, okay, the atoms are unexcited, unionized. Okay? So, for the chemical situation at which the flame could not dissociate the sample into neutral atoms. Ibig sabihin, pasabot lang ani that the flame is not enough to convert your sample into a atomic vapor, whereas in ionization naman is a situation at which atoms in the flame become excited and emit energy. So, ibig sabihin, yun yung interferences mo. If nasobrahan yung inyong pagpa-excite, diba? Kasi nga sa atomic absorption spectrophotometry, we do not want for the atoms to be excited, but rather, doon lang sila sa kanilang ground state, diba? So, we don't want that na ma-excited sila. Kasi pag naging ma-excite sila guys, that is ionization. Okay? So, I hope na-gets niyo yung difference nilang tatlo ha. The double beam, no, that has two type. The double beam in space and then the double beam in time. Okay? Ang space, meron siyang dalawang photodetectors. Ang time, isa lang. And then meron ng chopper, rotating chopper yung ating time. We also have the flame emission, which tawag yan, measures, di ba, the excited atoms, okay, excited electrons, whereas yung ating atomic absorption spectrophotometry, no, depende siya sa unionized, unexcited na mga atoms natin. Okay, so I hope na mo na-learn, no, and we can proceed to the part 2. Okay, so thank you so much. Hello future doctors and medical technology. So welcome back again sa ating discussion in the optical techniques. So now we're going to talk about part 2, which is luminescence. Okay, so when we say luminescence guys, no, it is the emission of light by a substance. Okay, so substances tend to absorb light and then emit, diba, light back. Okay, so it occurs when an electron returns the electronic ground state to the electronic ground state, diba, gaya na sinabi natin kanina sa previous topics natin, when an electron diba, jumps or becomes excited, as it goes back to its ground state, it releases energy in the form of light. Okay, so yung kanyang excess energy, no, will be released in the form of light or as a photon. So we have three types of luminescence: the fluorescence, phosphorescence, and the chemiluminescence. Okay, so let's talk about first the fluorescence. So fluorescence is when a beam of light is incident on a certain substance, they emit visible light or radiations. This is known as a fluorescence. So, isabihin, kasabot ang ani guys, no, when a certain molecule has been exposed to high levels or different levels or high beam of light, no, they will immediately emit radiation. Okay, so fluorescence starts immediately after the absorption of light and stops as soon as the incident light is cut off. So in this picture guys, no, as you can see, nag-emit siya ng ilaw, di ba? Ito yung ilaw niya. The moment na kanyang light source will be cut off, the light will stop immediately. Okay, so that is for the fluorescence. Whereas for the phosphorescence naman, when light radiation is incident on certain substances, they emit light. Same with your fluorescence, however, even after the incident light is cut off. So sa phosphorescence, even if the light source has been cut off, no, it will continue to produce, okay, or emit light, no. So this type of delayed fluorescence is called phosphorescence. So when we say phosphorescence, it means delayed emission of light. Okay, so yung principle nito guys, no, you can observe this sa mga glow stick, no, that are being used sa mga concert, okay, or even yung mga watches natin, diba? Minsan pag natatamaan sila ng araw and then after natin na maglabas, papasok tayo sa loob, no, nag-ilaw pa rin sila. That is phosphorescence. Okay, so for you to better understand this, the difference between fluorescence and phosphorescence, no, you need to take a look at this Jablonski diagram. Okay, so the Jablonski diagrams, no, better explain bakit ang fluorescence nag-ilaw siya as long as may light source, bakit ang phosphorescence is nag-ilaw siya kahit na wala ng light source. Okay, so remember that different molecules exhibits different types of light emission, okay, or light luminescence. Okay, so they may exhibit fluorescence or they may exhibit phosphorescence, depende sa molecule. Okay, so it can only be achievable, remember din, no, aside from the type of molecule that is being present, you need to take into consideration the amount of beam of light, no, na gina-introduce ninyo or yung light source ninyo. Okay, so in this diagram you can clearly see that you have the amount of light here, no, the excitation, no, which is 10 to the negative 15. Okay, so remember that your atoms are usually pair man na sila guys, no, ka-pair yan sila ganyan, and then they spin, no, on the opposite side. Okay, so once yung atoms niyo guys, no, ma-excite, no, merong beam of light na itama dyan sa kanila, no, merong energy, gaya ng nasa explanation ko sa ating flame emission, di ba? So they will tend to be excited, no, so ma-excite yan sila. Okay, they will go, no, to the, it's either to the first first electron station, no, in the singlet state, no, or the second station po. Okay, so they will be excited, no, either dito sa dalawa, and then after nila na ma-excite, di ba, remember kailan na sila mag-release ng kailan sila maka-lose ng energy? When the excitation stops. Tama. So bakit nga sila ma-excite, no? As they become excited, they absorb light. Okay, remember, nag-absorb yan sila ng light in an excited state, no? So let's say for example here, the excitation given or the amount of light given is 10 to the 15, no, negative 15, 10 to minus 15, and then, no, kapag nasa singlet state na sila, no, eventually, no, the excitation will stop. Okay, the excitation will stop and they will emit low energy na photon. So since photons man, kaya visible yung ilaw na ma-emit niya. Okay, in the fluorescence case guys, no, kaya siya as long as merong light source, no, merong ilaw na pinapalabas sa fluorescence because the amount of light na nandito sa inyong beam of light or your light source is greater than the emitted light sa fluorescence ninyo. Okay, let's say for example the amount of light given is 10 to the minus 15. Ang ginabigay niya na light, okay, binibigay niya na light niyo in the fluorescence is 10 to the minus 9. So ibig sabihin guys, no, the amount of light absorbed is greater than the amount of light emitted. Okay, yung ginapakita niya. So pag mag-stop na to, no, mag-stop na tong inyong light source, no, mag-stop na rin to agad because the amount of light given is mas mataas, no, mas mataas compared dito. Okay, so how come sir ang phosphorescence sir is matagal siya mag-ilaw? Okay, ganito kasi yan, no, same thing, no, ang starting point nila will be the same, no, but there are some molecules that undergo fluorescence or phosphorescence, no, depende dyan na siya guys. Okay, so same sila ma-excite, However, no, in the phosphorescence case, guys, in the phosphorescence case, no, the molecule or the atom itself, no, instead of being unexcited, no, being na dili siya ma-excite, it will undergo a transition to a triplet state. So when say triplet state, ganun sinabi ko kanina, no, atoms are usually paired together and spin in the opposite direction. But however, in the triplet state, no, they will spin in the same direction, or sometimes mabaliktad pa na sila. Okay? So since the atom, no, undergoes these changes, no, these changes, okay, yung kanilang light na na-absorb, no, or yung kanilang pagiging excited will be longer. They will spin longer. Na-get so far. So if they spin longer, no, sa kanilang out sa ilang orbital, no, so ibig sabihin dili sa sila makapagawas og energy, no, wala pa kasi hindi pa man sila makabalik sa ground state nila, matagal man, no, may time delay man, kaya delay yung ilaw na pinapalabas ng phosphorescence. Okay, so after that long delay of spinning, no, magiging unexcited na po na sila, no, as they become unexcited or as they go to their ground state, no, they will now release energy in the form of photon. So therefore maka-release gyapon sila og energy bisan wala nay light source. Na-guess niyo? So I hope na intindihan niyo, no. So importante yung fluorescence at phosphorescence, guys, no, but ang gina-utilize natin sa lab is yung fluorescence. Okay, so bakit man, sir? Because makita nyo naman, guys, no, depending on the excited the light source na gigamit mo and then the analyte that you want to measure, you can clearly measure, guys, no, kung gaano kadami yung amount ng electrons na present dyan, because hindi mo good equal ang amount ng light na gina-release ng fluorescence mo compare sa imuhang starting na light source, 'di ba? So yun siya. So ang measurement diyan, no, ang measurement of fluorescence is what we call fluorometry. Okay, so remember that in fluorometry it is the measurement of fluorescence. Since the energy given off, given off is less than that of absorbed, na yung absorb niya. Okay, given off is less than that of the absorbed. The wavelength of light given off is usually longer than that absorbed. Okay, so here as you can see, you have a blue light which is high energy. Remember, 'di ba? Pag high energy, mas sila, no, ang wavelength nila mas dikit-dikit, mas shorter ang wavelength, tama? Since ang kanyang after na excited state, 'di ba? Sabi ko, maging ground state na yun siya, and then eventually will give, tama? Will emit energy in the form of photon, no? Mas lower na yung energy na gina-emit niya, therefore mas longer yung kanyang wavelength. Okay, the wavelength of light given off is usually longer than that of absorbed. Okay, so yun yung difference nila. Remember, guys, no, emitted fluorescent light has longer wavelength, tama, therefore has lower energy. It is due to the energy loss between the time when a photon is absorbed and then when it is emitted. Since the energy given off is less than that of absorbed, the wavelength given is usually longer than that of absorbed. Measures the fluorescence or the energy emission that occurs when a certain compound absorbs electromagnetic radiation, become excited, and then return to the energy state that is usually higher than their original level. So basically, based on this diagram alone, guys, no, you can clearly measure kung ano yung analyte mo. Magets so far? Kasi let's say for example, nagbigay ka ng 500 na light source, no? Your electron atom will become excited, diba? Will become excited, and then will now release, let's say for example, 580 na lang, will release 80, low energy. Okay? 80. So since nakita mo na 80 lang yung kanyang gina-release, therefore you can conclude na ang light absorb niya is 500, diba? 500. Kasi 580 may binigay mo, 500 yung absorb. Based sa kanyang light na emit, you can now compute the amount of energy or light absorbed by that electron. Okay, but remember fluorescence and phosphorescence happens, or it depends on the type of molecules as well as the type of light na gagamitin nyo, the beam of light that you're going to use. Okay, so what else can we learn about fluorometry? So fluorometry, no, emitted light has longer wavelength than the incident or excited light due to the loss of energy during collisions, transfer to other molecules, heat loss, and other emissions of radiant energy. So here in the diagram, guys, no, makikita ninyo na medyo it has the same parang it uses the same principle of your, ano guys, of your, tawag yan, spectrophotometry, tama? Yes, sir. So, it uses the same principle of your spectrophotometry. However, there are certain filters na ginagamit po dito para mas maganda yung kanyang pasok. So, you have your light source here, no? And then, after ninyong light source, guys, no? For the fluorometry, remember, gagamitin dyan na light source, but let's say, for example, mercury na ilaw, okay? Mercury emits ultraviolet light and visible light, okay? UV and visible light, okay? Wait lang. Ayun, sorry po guys, no, because yung dog ko kasi yung nagka-problema. So anyways, where was I? So as you can see here, no, yung, let's say for example, mercury yung gamit natin ng ilaw, it emits ultraviolet light as well as yung ating visible light. Okay, so since it emits on ultra and visible light, no, as it pass through with your attenuator, okay, it needs to undergo, no, it needs to pass through the primary filter. Okay, bakit kailangan ng primary filter, guys, no? It needs primary filter because ang only na ginapapass through lang natin dito is the UV light. Okay, so depende jud na siya kung ano yung gagamitin na filter dito, guys. So depende jud na pud na sa test na gagamitin natin. Okay, so after that, the sample holder that holds the sample, no, the electrons present, the molecules that you are testing or the analysis you're testing now will now undergo yung process kanina, no, the fluorescence. Okay, so since mag-undergo siya ng fluorescence, there are some, tawag yan, lights na ma-emit, no, in the photons in the form of light. Okay, and then they will undergo secondary filter. The secondary filter here is there to stop, okay, to stop tawag yan, unwanted lights, no, unwanted na mga lights na pwedeng makaano sa right angle, yan sila nakaposition, guys, no. The secondary filter there is nandyan siya to stop the unwanted light. Okay, ang ipapass through niya lang talaga dito sa inyong towards your photo-detector will be yung ating emission or the emitted light. Okay, so i-ano na siya, guys, no, lahat ng mga hindi need na unwanted light will be filtered, and then only those wanted light or yung mga light na gusto natin i-test coming from your sample will be the ones who will be detected by your detector. Okay, so after that, since meron tayong photo multiplier dito, remember, photo multiplier can amplify, no, kahit gaano pa yan kaliit yung ilaw, therefore can give a better readout. Okay, so yan siya yung ating fluorometry. Okay, to give you a better diagram of this, let's see, ito siya, guys, no, from your light source, let's say for example a mercury. Okay, it will undergo primary filter, no, and then towards your sample, the sample will emit light and will undergo secondary filter. Okay. After that, it will be read in your photo detector, no, or your photo multiplier tube. Okay, then read out. Okay, so same principle sa mga nabanggit ko kanina, no, but this time may diagram na tayo. So ipa-drawing ko yan ng spectrophotometry, no. This is very different from your spectrophotometry because this one has your have your primary filter and as well as your secondary filter. At the same time, the light source used here, no, is kana mga high energy na mga ilaw, no, such as your mercury vapor lamp or mga xenon arc. Remember, xenon arc and mercury, they can emit ultraviolet violet light, tama, and as well as UV. Depende dyan sa mga test na i-perform ninyo. Okay, para meron pa kayong mas simpler na diagram here, meron tayong light source, no. Here is your initial light, no, the initial, after the primary filter, secondary filter, or the emission monochromator or filter pa rin, and then photo detector, no, using the photo multiplier na tube. Okay, so let's try to understand the different components of your fluorometry. Okay, so light source, mercury vapor lamp or xenon arc lamp, no, ang excitation or your primary filter natin, no, it select the wavelength that is best absorbed by the solution to be measured. So depende jud na kung anong i-input ninyo na gusto nyong titignan. Cuvette, no, alam naman ninyo different types ng cuvette natin. And then we have the secondary filter or the emission, no, secondary monochromator, filters out fluorescence from stray light radiation, position at a right angle from the cuvette to eliminate potential interference from the excitation line. And then diretso na tayo sa photo detector. Okay, fluorometry, no, since nag-emit tayo ng different types of light, depende sa molecules or analytes na ating gina-test, no, it can present different types of color. Ayan. The advantage of this is it increases the specificity by selecting the optimal wavelength for both absorption and fluorescence, no? Since you can dictate what type of tawag yan, molecule that you want to test, no? So pwede ninyo mapili talaga yung light na gusto ninyo. Okay, emitted radiation is measured directly, okay, because dumaan na siya ng mga filter, no? Meron secondary filter or the emission filter. However, the disadvantage of this is very sensitive to environmental changes. Yes po, kasi once na merong stray light na makapasok dyan, since fluorescent siya, no, they will tend to absorb those light as well. Okay? And then, ang pinaka-main, niya guys, no, ang pinaka-main na disadvantage niya is since makat off siya, the moment na makat off ng light source, no, is quenching. Quenching is the quick disappearance of fluorescence, no. Can be changes in pH after electron availability, temperature changes, the probability of loss of energy, contaminating chemicals, or a change of solvent may change the structure. So, ano siya guys, no? Maraming disadvantage po ang fluorometry. Okay? So, let's take a look at the third one, no? We already talked about the fluorescence, phosphorescence, no? And now, let's talk about the chemiluminescence, okay? So when we say chemiluminescence, guys, it is the production of light from a certain reaction. Okay? So ano siya guys, no? Tawag yan. Yung kanina yung nabanggit ko regarding sa phosphorescence natin guys na mga glow stick, no? That is yung sa watch, no, that is valid po 'yun, tama po yung sa watch, but yung sa glow stick guys, no, my bad. Under chemiluminescence yun siya. Kasi ano na pala ngayon ang mga glow stick natin eh. Man-made pala siya. Man-made siya, gawa ng tao. Okay? So, remember, under this, the excitation of the substance does not involve electromagnetic radiation and no monochromators are needed. Okay? Instead, the excitation of energy comes from a chemical or electrochemical reaction. Light signal is measured against a completely dark background and involves the excitation of an organic compound. So, ito yung sa glow stick natin, no? Ang glow stick, guys, no? Kaya siya gonna-bend para mag-produce ng light ng hydrogen peroxide solution. You have your hydrogen peroxide solution here. And now you have your, the phenyl oxalate ester and fluorescent dye solution. Once na ma-break yan siya guys, no? Yung ma-break yung nasa glass vial as well as itong glass, yung hydrogen peroxide is encased in a plastic casing. Your phenyl oxalate, no, is in the glass vial. So after niya ma-break yung glass, no, the reaction will lead to a chemiluminescence, no. So dito guys, walang involvement ang light source, no. Hindi ka gagamit ng mercury lamp, xenon arc, or mga flame para mag-emit ng ilaw, but rather because of chemical reactions kaya siya umiilaw. Yun lang talaga siya guys. Okay? So we also have yung tinatawag natin na nephelometry. Okay? Ayan, nephelometry versus turbidimetry. Okay, so when we say nephelometry guys, no, light scattering is a physical phenomenon that results from interaction of light with particles in solution. Unlike fluorescence emission, the wavelength of the scattered light is the same as of that incident light. So ang nephelometry guys, no, kay ano siya, parang kung sa fluorescence po, yung inyong incident light, no, yung binigay na ilaw is greater than yung sa kanyang gina-emit na ilaw, no, yung kasi di ba gi-absorb niya yung ilaw, then mag-emit siya, no, ng energy, the form of photon, no? Then light, mas mataas yung na-absorb niya compare sa kanyang gina-emit. However, when say nephelometry guys, no, same lang sila. The wavelength of light, wavelength of scattered light is the same as of incident light. Kung tawag ang incident light mo is 100, no, ang scattered light po is 100 po na siya. Okay? Ang emission niya. Okay? So that is for the nephelometry. Okay? Ano pa? Ang technique mo guys ganito. When we say turbidimetry, it measures the amount of light blocked in a particulate suspension, no? The decrease in light transmission. You have the nephelometry measures the amount of light scattered in a particulate suspension at a 90 degrees angle. So here, pag sinabi mong turbidimetry guys, no, ginadetect niyo yung amount of light na gi-block in a particulate suspension. So there will be a decrease in light transmission. So if you have a light source here, no, pag sinabi niyong turbidimetry, kung 100 yung light source ninyo guys, no, titignan kung ilan yung ilaw na block ng inyong suspension. Let's say for example your suspension was able to block 50, no, block 50 na light. And then yung babalik sa inyo na light is syempre mas lesser na compare sa inyong original na ilaw. Okay? So therefore you can calculate no the how much kung ilan yung sa inyo how much light yung nandiyan sa inyong suspension. But this type of optical techniques are very very not so reliable, no, because for example dito lang light black lang siya ng particulate suspension. Okay? So naga-base na siya sa light black. For the nephelometry naman, no, measures the amount of light scattered in a particulate suspension at a 90 degree angle. Okay? For the nephelometry guys, no, kung a light source mo is 100, no, tapos pinatama mo siya sa suspension guys, no, ang gina-measure dito is yung light na gina-scatter. Lahat ng light na gina-scatter dyan will be measured accumulately, and then it should equal yung ating 100. Okay? Kung for the turbidimetry, it is less than the light na imuhang incident light. For the nephelometry, it should be equal. Light scattered is equal sa light na introduce. Okay? So, let's see ano yung kanilang mga application. Okay? Nephelometry is a useful method to determine the concentration of solution that contains particles too large for absorption spectrophotometry. So remember sa atomic absorption spectrophotometry guys, no, we tend to vaporize na the specimen, tama? Here, hindi siya pwede. Pag hindi pwede yung absorption guys because the particles are too large, no, we use yung tinatawag natin na nephelometry. So same principle sa sinabi ko kanina, no, from the light source, okay? So tatama yan dyan, and then yung scattered light, it should be equal sa light source natin. Okay? Yan yung kanyang guys, no, yung tinitingnan niyo yung scattered light. Okay? In turbidimetry guys, no, the amount of light passing through a solution is measured. The higher the turbidity, the smaller the quantity of light, because gina-block nga, 'di ba? Blocking, when we say blocking, the more light is being absorbed by the specimen. Any spectrophotometer or photometer can be used as a turbidimeter without modification. Since property concerns visible light, no, the measurement is commonly carried out at 420 nanometer. In nephelometry naman, on the other hand, the detecting cell is placed at the right angles to the light source to measure the light scattered by the particles. The intensity of the scattered light serves as a measure of the turbidimetry. The instrument is called a nephelometer or a nephelometric turbidimeter. Okay, so that's why makita nyo sa diagram kanina, halos same lang sila. Okay, diba, halos same lang sila. But however, remember, in nephelometry guys, no, involved na dyan yung light scattered. Okay, aside dun sa mga yung kanyang principle, no, na it is used in conjunction with your in conjunction with your spectrophotometer. So how does this work? Remember, your spectrophotometer can be used as a turbidimeter, diba? So pasabat if you want to use nephelometry as well, you need a special attachment. Okay? Kasi ididikit man gud yan guys, no, sa loob ng machine. Ilalagay yan siya doon. Okay? So we have some difference guys, no. Another difference sa dalawa aside dun sa mga nabanggit sa inyo. Una, the type of light source that they use. Okay? So remember, nephelometry uses mercury arc lamp. The turbidimetry, tungsten lamp, no, which is very common sa ating mga spectrophotometers. Sa nephelometry, scattered light is measured. Turbidimetry, light transmitted is measured. Okay? So a measurement happens at 90 degrees. Ito naman measured in straight line. Okay? Meron tayong photomultiplier tube is the detector, and then dito photocell is the detector. Okay? So yan yung difference nilang dalawa. Ayan. For the diagram, you can clearly see na meron kang nephelometry. Okay? Nasa right angle sila, no? Nasa hindi sila straight line, no, yung pag-measure ng ilaw. Whereas for the turbidimetry, no, nasa straight line yung kanyang pag-measure ng light, no. So guys, can you use both of them at the same time? Yes po. You really just need a special attachment or another attachment for this to work. Okay? So you have different factors that affect the light scattered, diba? So you have the particle size, concentration of particles, the molecular weight of the particles, and then the wavelength dependence. Okay? So we have three types of scattered light. You have the Rayleigh, no, wavelength of light is greater than the particle size. Okay? light symmetrically scattered around the particle. So this is really scattering, no? So ibig sabihin yung ilaw na yung light na ano niya guys, no, scattering niya is symmetrical, okay, around a particle. That is really. So you have your MIE, no, wavelength of light. Again, wavelength of light is less than the particle size. Okay, light scatters backwards but appears forward due to the destruction out of phase background scatter. Okay, so another thing to remember about this, no, example is that clouds are white because light from the sun is white. As light passes through a cloud, it interacts with the water droplets that are present in the cloud, which are much bigger than the atmospheric particles that exist in the sky. Okay, so yun yung ating example po dyan. So we also have the Rayleigh divide, no? Wavelength of light is equal to your particle size, no? So tandaan ninyo, pag wavelength of light is greater than particle size, Rayleigh na siya, so ibig sabihin symmetrical ang kanyang pag-scatter. For the MIE or the May, no? Wavelength of light is less than the particle size, okay? And then meron tayong Rayleigh divide, no? Wavelength of light is equal to the particle size. More forward light scatter, antigen, such as your antigen antibody reaction. Okay, so I hope again na learn ninyo yung different types of optical techniques natin, no, since from the very first meeting natin, I think I explained to you everything that is to know about spectrophotometry, other techniques, no, that can be used in conjunction with your spectrophotometry. And then I hope sana you supplement this again lecture with reading, no, yung ating reference books. Okay, so thank you so much for listening and see you next again in another episode of CC1 lecture. Okay, so thank you for listening. Bye bye.